Next, this week we have class. Next week is going to be a spring break. And I hope you guys have planned for a spring break. Okay, after spring break, you're going to have your next exam. All right. Does anybody have any question for me before we continue with the class? Okay, but if you do have a question for me, you're welcome to ask me after class. Okay, so I'll be happy to help you out. All right, then I'm gonna continue with the section that we have to study on. I want to remind you something before I continue about the difference for population. Let me just, where's my pencil again? No, I'm using PowerPoint. Whenever you're dealing with a population, population is a group of people, object we wish to study. Whenever you have a population, two things can happen, because what we're going to be studying in the class, we're going to be studying something called the mean. The mean for a population, or the average. We're also going to be talking about something called a proportion. Proportion. So these are the two key things we're going to be taking on your class. One's called the mean, the other one called proportion. Mean, you can say mean or average. Both of these things also called average, by the way. So, but we can call this one average if you want to. The average for mean and the other one for the proportion. So the expression that we use for mean is the symbol right here. It's called, it's pronounced as mu. Is mu, pronunciation is mu. MU. And whenever you talk about proportion, we use the symbol P. P, letter P, lowercase p. Okay? So you got the mean mu. You got proportion P, and you got a third one. A third one that we call standard deviation. Standard deviation. We talked about it before. The symbol that we use for it is this one, like this. And the pronunciation is sigma. That's the pronunciation for it. So you got the mean, mu, the proportion P, standard deviation, sigma. Okay. These are things that we spoke before at the beginning of class. I mean, some people spoke about them. Okay. And then let's see again. So then the thing I just showed to you right now, they are called parameter. Okay, parameter is a numerical value that characterizes some aspect of the population. So for population, the example for the parameter will be mu, P, and then sigma for now. They are called parameters. Okay. For you to get those parameters, you must do something called a census. Census, like you have to get information from every member of the population. You must do a census. We don't have enough money to do a census. If I ask you to do a survey for me, we don't have the resources for that. But the state does have it. The government does have a resource for it. But we notice that we can do something called give me one minute, somebody's got in. We can still do something like find a sample. If you do a sample, that'd be easier. A small portion of the population. This will give us an idea of the entire population. Okay, so you can use a sample. Example for the element that we use for the sample, they are called statistic. Okay, example of a statistics is gonna be X bar for the mean, which we saw before. It's gonna be P, we follow the hat on top of it. This one is new for you. We're gonna call it P hat for proportion. And the last one is gonna be S, the lowercase s, for standard deviation. Okay, they are called estimators for X bar. That means this what happened. X bar try to get an idea of mu. P hat try to get an idea of P. P is for the population, while P hat is for the sample. So don't confuse them. P hat, it tried to get an idea for P. And then S, you try to get an idea for, so about that thing going on here. Let me just erase it again. S, while S is trying to get an idea for sigma. So that division of the population. Okay. Any questions so far? Any questions? Yes, no? No question. It's that thing we were doing before. Now, when you talk about something, this is what happens. Whenever we do these things, we're gonna do something called inferences or conclusions. You're gonna have an idea about the population. This is called statistical inference. Once you use data to make conclusions, to do your choice, that's mean you did a statistical inference. Okay, you draw a conclusion about the population based on some observation you did. Okay, so before, suppose you want to take a class, some people, what they do, they like to do some research. They look up the teacher first, the professor, and get some ideas. You look at data about the person, the rating about the person, and so you know what, even though the teacher is really bad, I'm just going to take him anyway. Or even though this one is, I'm going to get him because you already know what to expect for. Or this one is really good, I'm going to take him anyway. This is what you did, which is called a statistical inference. You draw a conclusion about some observation that you did. You went out there and make some research, and then you make a conclusion about it. Okay. So at the same time, that's something we need to learn, that statistical inference always involve uncertainty. So we're gonna put them into something, you don't know what's gonna happen, but that's why I say there's uncertainty. Okay. You base your knowledge on uncertainty as well. But with statistical inference, with the data that you do, you're confident enough that you make a right decision. You're confident enough, say, I want to go to TCC. You make your research, then say, I'm confident enough, I'm going to go to TCC to do my classes, or I'm going to go to Harvard University to do my classes. You're confident on your choice, but it still involves uncertainty. Okay. That's something I want to point out. Just a quick example I want to show you quickly. Over here, there's an example. Oops, one button. Where's my cursor? I keep losing the cursor all the time. Okay. Now, this one say a survey asks 1,000 US college students if they prefer to study alone or for other people. 420 of them prefer to study alone. Okay. Notice that they surveyed 1,000 people, US college students. Okay. We would like to know what will be the parameter, the population here. So notice that if I study 1,000 students, US college students, this will give me an idea about US college in general. I took a sample of 1,000 to get an idea about the entire population. Okay, the population will be the entire US college students, all the US students in the United States. That's the population. And then you have a sample of 1,000. Okay, and I mean, you take a small sample, n is equal to 1,000. That is study. This probably will generate either a p hat. This will generate either a mu, or it can generate either a sigma and a sigma, something like that. I'm not sigma, I'm sorry. Not mu, I did the wrong thing here. And I'm thinking about the other one. You just put that one instead. This can generate either X bar, which is the mean. It can generate P hat, and it can generate the letter S. While for the entire population, we generate a mu for population, P for proportion, and S and sigma for standard deviation. Okay? Just want to make sure you understand the idea behind that. Okay? Now, let's talk about the parameters one more time. Here, the parameter, okay, this one said the parameter of interest is P. Now, they're talking about proportion here. So if you could, whenever it's the P, it means proportion. So we select one of proportion. Okay, P. So what does that mean? The parameter P. Okay, we can find it. Okay, so it's proportion of all US colleges in the United States. We can find it. Okay, but it's gonna be hard. But the best one to do is to do a statistic, find P hat. Okay, how do we find P hat so easily? This is very easy to get P hat. Notice that we got 1,000 people. N is 1,000. That's we can do something like this. You can say P hat is equal to X over N. This is a fraction of the students that don't like to study for the people. Okay. I'm sorry, I'm not supposed to put N, so to introduce a formula to you. So just put N right here. Let's put my pen, that'll be N. That's mean here, I've surveyed 1,000 students, and then 420 of them prefer to study alone or with others. And this is gonna give you 0.42. If you want to put to decimal place, you can use 0.420. So it's about 42% of them say they like to study alone or with other people. I can say about 42%. Okay. Notice that P hat give you an idea of P, which is the entire population. So you can go ahead and say, you know that in the United States, people like to study alone or with others. You can say that. You can say about 40% of the people like to study alone or with others. Now I can say that based on your sample. Okay, you didn't have to go and survey every single student. I mean, like doing a census. You don't have to go and then you don't have to go and survey every single coalition in the United States, which is going to be hard. Okay, but you survey about 1,000 of them, then you can get your conclusion. Okay, then after that, what I mean by conclusions, I mean doing the inference, the statistical inference. This is when you do the conclusion. You can say, we estimate that 42% of all students, all US college students prefer to study alone, something like that. Okay, so based on your conclusion. So this, the little sample that I have, help me to give an idea of the entire population. The same thing we do whenever somebody dies. If somebody dies of a crime, you don't keep the entire body of the person. You took samples. That sample that you took will give an idea of the entire body. Okay, so you need to give the body away. So the family to the back, you take samples. You give it. That's what we're talking about. A sample will give an idea of the entire population. Okay, so if you have no questions, I'm going to be continuing. These are stuff I want to point out to you. It's something called bias. With this, the idea behind bias that we say that because we're talking about proportion. We have two of them, right? We have proportion, the mean, proportion. We just did this one. P hat is try to identify P. But as proportion for the mean, we have mu a X bar, try to express mu. And then for the standard deviation, we have S, which is trying to express standard deviation sigma. We say that these values are called unbiased. They are unbiased. They're not biased. They're unbiased. Bias estimator. Okay. So we assume that whenever you take the decision, we're gonna say that is gonna be the best for our knowledge. Something is biased if you have, I would say it's biased if you have to support something that is not true. Okay. So these are things you can read on this side. Is the opposite of unbiased. Okay. For example, suppose I don't like Republicans, for example, and then what I do, I ask people on my neighborhood whether they like Republicans or not. So what I do, instead of asking every single person, I mean, instead of asking people on the street, what I do, I only ask my family members who already know that I don't like Republicans, who already know I don't like Democrats. You understand? So of course, my result will tend to go toward what I want. So that's bias. This is not an unbiased result. This is not acceptable in statistics. Even though statistics is not an exact science, but whenever you do study, you have to be unbiased. Okay, you don't try to look for the result where you already have an idea behind your head that you can trick the system. Okay, just to make some people to get to look good or to look bad. Okay, and then there's some couple stuff on there on the file here that you can just read on your own. I'm just gonna skip that. This is for you to read because this is just information for you to read. Okay, read those things. That's another example they give you. Can just read it also through it. Okay. Okay. Now, for the sample random, so the only thing I wanted to point out to you that whenever we take in our samples, because we should remember that we took 1,000 earlier, we took 1,000 people out of many in the United States. So we want to try to understand that they also, whenever you take a sample, it has to be random. Where is my cursor again? Whenever you do a sample, it's random. Remember that it's going to be random. Oscar, it says sample random, but this is also for you to read that part here. The only keyword I want is random. Okay, random sampling. Okay, I'm going to say SRS, which is sample random sampling. Okay. So what do you mean by random? So I'm going to skip a few things. I'm going to talk about right here. Whenever you select your sample, random doesn't mean something that is random. Whenever it's something, there's going to be some error. It doesn't have to be specific, but it can be close to the truth. Sometimes we can overstate in something, sometimes I can not overstate. Like for example, this picture here, you take something like this is an idea of precision here and accuracy. Here, the little picture show that something that is both accurate and precise. The second picture show that something that is precise but not accurate. The third picture show that something that is accurate but not precise. And the last one say a picture that is neither one. Okay, so whenever you're gonna draw your sample, I know some people say, well, how did you get a select the 1,000 people? You just select 1,000 people out of the population of the United States, that college students. You go and ask them questions. And then at the same time, if I want to select my population of people who study in the United States, I don't have to go to Canada and get the information from people in Canada. You understand? So it has to be true to what I'm doing. It has to be accurate and precise. Okay. Sometimes, even though I'm getting precise, there can be some little error. Okay, I can be overstating, underestimating, overestimating, or I can be exactly to the truth. Okay, so then what's gonna happen here? We talked about bias before. Where's my? I keep losing the pen each time. Okay, so here is we're gonna talk about unbiased. Okay, but the things that bias is a measure of accuracy. So this is an example, just look at to it. But the key word I'm worried about here is something called standard error. Whenever you find your p-hat, for example, if I'm talking about the population here, when I'm talking about population, population. Suppose I'm talking about the proportion. Once I get my sample, I can generate a p hat in which X of n people doing something. That p hat can either be off or close with something. So that p hat right here can be plus or minus some error. Okay, closer to the p. Okay, there will be some error, either plus or minus. If it's a proportion. If it's the mean, we're gonna do the same thing as well for the mean. So what we have for population mean, this is for a sample right here. And I'll go for population mean, for the sample, I can generate something called X bar. Okay, that X bar will be either plus or minus or some error. Okay, that will give you the mean mu. Okay, so that's why I want to introduce you about something they call the standard error. We're going to be talking about that a bit more today. Okay, so I'm going to skip a couple of slides again that you can just use for you to read. Okay, now this one is interesting before you do. This one will help me understand how to calculate the sample. That's interesting. And let me go over that quickly. As you can see here, we have a small sample which content of Mike, Rick, Sue, and Mary, and Rose. Notice that we have 2 guys out of 3 women. So we got, if you want to find p hat, p, this is suppose this is the entire population. Okay, suppose this is an assumption I'm doing just to give you an idea. Suppose this is the entire population. Okay, population. Okay, so I'm talking a person of male. So I will be P is equal to X over N. So I'm going to say how many males do we have? We have 2 males out of 5 people in total. This will give you 0.40 or 40%. That's in 40% of the people that are given here are male. While the other 60% will be females. That's the idea here. This is what happened. I would like to select a random of 3 people. Okay, just 3 people only out of these guys. So if I want to select 3 people only, so I can either, let me just use a different color. Suppose my first one that select will be, let me use a different color, that's blue. Let's use, for example, Rick, Sue, and Rose. So Rick, Sue, and Rose. Like this one right here. Rick, Sue, and Rose. That's my first selection. Okay. So if I put Rick, Sue, and Rose, so I got 2 people here, right? This is my sample. This is what happened. So I can decide to choose Rick, Sue, and Rose. Somebody can choose somebody else, etc., and so on, right? But notice that from the sample, I can generate something called a p hat. Okay, this is a sample. Where's my cursor again? So I can generate a p hat here. I can say p hat is equal to X over N. Note, in that case, the sample here is 3. But how many males do we have? We only have 1 guy. That's going to be 1/3. Okay. So it gives you 1/3. So what I have here, I got P, which is going to give you 0.32%. 0.33% if you want to wear it. Okay, 0.32%. Then you can do a suppose you select a standard group of people, Mike and Weeks or something like that. This is going to be the same thing. Okay, because you got 2 guys and 1 woman, so that has to be 2/3. Okay, and so on. But notice something carefully. If I cannot give myself the liberty to erase that part here because I see how I got it. So let me just write down for you here. So we did, to get the 133 here, we did 1 divided by 3. Here we did 2 divided by 3. Now remember that from the population, we have 40%. Okay, that means this is what happened. If you can do something like this, it can be like over there. If I do what can I do? I can do P minus P hat. P hat, this is P hat instead. P hat minus P. So this is gonna give me an error of about, if you do 33%, take away 40%. So this is gonna give you about 13%, right? No. 40 take away 30. That's gonna give you 7%. Okay. So here you have an error. I mean, that's mean I'm off here. I'm down. Like it's like here, I underestimate by 7%. Okay. Like compared to this one right here, if I do 67 minus 40%. Okay. When I took Mike, Nick, Rick, and Rose, and then my solution here will be 600. That's going to give you or 27. Here, I overestimate by 27%. So we have error each time we do it, but you can also have a standard error, okay, which I'll talk about in the future, like an average of all the errors, okay? So that in the future, I can just say, here we have P hat. You see this, you got P hat minus P, will give you some type of error, okay? So that's the error. This is how far you are away from the truth, okay? Because it's not gonna be 100%. There'll be a bit of error, okay? In the future, we're gonna have something like this probability that will go like that. So based on the graph I just showed you right now, you're gonna have something that go like this. You're gonna have either P hat plus or minus some error. If it's a proportion, that will give you P. If it's the mean, you can have the mean mu plus or minus some error. And I will give you, I'm sorry, I mean X bar. Just put erase that, we put X bar. That'll be X bar plus or minus some error. That's going to give you the mean mu. Okay. So the reason I did that is because whenever you move the P on the other side or whichever you want to do, then it changes that way. Okay. So we also can go further. Like you're supposed to get Sue, Mary, and Rose, then you got a proportion to get the guys, that'll be 40%. That's mean you can be off the chart. That's a possible as well. Okay. So it can happen that whenever you select your sample, it can be off the chart. But must assure that your sample is random and it is your best estimate. It is the one that you select from the population itself. You know, something that you take from out of the population. If you're talking about the United States population, you're gonna go and introduce and get people from Canada or people from Mexico. It has to be the US population, college students in the United States. It can happen that your proportion can be 0. It can also happen. Okay. So if any questions so far? Okay, so let's keep walking. It's not the marking again. I think I did myself clear enough on that part. So you just want to say one population proportion many sample proportions. That's we can have plenty of proportion for whenever you select your sample. Okay. So not only that, that's mean if I'm doing a study, we're doing the same study. Once our study just cannot be identical. Okay, that's what it means. Here we talk about the standard deviation here. We are learning about standard deviation before. I'm going to skip that ID just for you to read this part. This is the same idea we were talking about earlier. Suppose that's kind of close to what we want to talk about. Suppose you consider a population of 1 million. Suppose a population of 1 million people. They say 40% of them are male. What you're going to be doing, you're going to select 3,200 of them, of the population, because you do not have the resources and everything to go and survey probably in 30 days, 1 million person. Maybe you don't have the resources, unless you just don't sleep. Okay, but you can select 300 people, probably survey a 10 of them per day. Survey 10 people per day, give you 200 people for a month, something like that. Okay, so this is what happened. Here, the mean is 40%. How come the mean is 40%? Okay, so that's an example. Okay, if the mean is 40%. Standard deviation can be 2.8%. That's an example. Okay, I'm giving you an idea. That's a standard error. And then here that notice that the mean sample proportion equal to population proportion. Okay, so the standard deviation, the standard error is 10 times smaller than when the sample size is 100 times larger. So that's extra thing that you want to understand. Okay, so this one here for the sample, if you look at the all possible answers, this is if you look at all the possible answers. This is the same thing we're talking about earlier, where that's the tempo you can read on your own. And then the mean will be to 40%. I will show you right now how to find the standard error. I'm going to show you later on today. Before I finish today, I'm going to show you how to get the standard error. But the way I show that, do not confuse population and sample. So that's two different things. You select the sample out of the population. Okay. Okay. Suppose they say 40% are male. This is P is given to you right here. Okay. They already give you the P. All right. But because that's what happened, the reason why we say the mean for the sample is 40%, because P hat try to express P. Okay. Another way you can say the mean sample proportion equals the population mean. Okay, so that's the idea behind that. But this is just an estimation. This is just an idea. Okay, this is whenever you choose the right sample, but that's not going to be a specific sample. Okay, again, I will explain how to find the standard error soon. But now that's why I'll keep skipping a few things. Okay. Now, I will show you how to calculate the standard error using the proportion for now. And after that, we're going to do it in the future. We're going to do it for the mean and for and so on. Okay. So thank you for the questions. Jacob, I will come to it. I'll be answering the questions soon. Okay. So the mean of all sample proportion always equal to the population proportion. I mean, that's the way they want to express it. Okay, the standard error will be smaller for larger sample size. The larger your sample size are, the smaller will be your standard error. Okay, I saw some of you did that missing in the exam. If you have a bigger sample size, your standard error, even the standard deviation will be smaller. Okay, things are again for you to read. Okay. So let's go back quickly right here. I'm going to skip this one for now. Let's go back. This is how we calculate the standard error. Okay. So in that case here, don't let this one a bit confuse you. This is your general idea. Whenever I put mu subtitle P hat and sigma subtitle P hat, is a general idea. This is what I mean. Whenever you have, in this case, this term means average. That's a general term. Average values. Okay, so it means an average value. In this case, I mean by average value for mu P, if I put P hat with it, and then that's mean that's going to be P. Okay, that's the idea behind that. If I put mu like this, and I put X bar, like this. That's just gonna give you mu. That's the idea behind it, okay? So don't get lost. I know the way the book is writing it are kind of creepy, but I want you to focus when here, because you use P right here, this is for proportion. Whenever you select the P right here, this is for proportion. Okay, this is proportion. Proportion. Whenever you see that P, I mean proportion. If you don't see the P hat, if you are X bar, this is for the mean. Okay. All of these are called average values. Okay. So let's go. How do we calculate the simple side? Here earlier today, I give an example. Let me look at the example we did before. Earlier we had P was equal to 0.40. Okay, that's what we had earlier. And after that, we had what is the population again? We had N is equal to 3. Something like that. N is equal to 3. We can find it for the other one too. No. Let's find the example we just did. N is equal to 300. Yeah. N is equal to 300. I think that's what I want to do, right? So how do you find the standard error? Standard error, you had, is equal to, this is for proportion. That's why I calculated the P. That's an indication for me. This is a proportion. This is equal to 0.40 times 1 minus 0.40 divided by 300. That's going to give me square root of 0.40 times 0.6 divided by 300. So I'm going to use a calculator and find this one. That means this is going to be the square root of 0.4 times 0.6 divided by 300. Okay, so I'm going to use my calculator to see what I got here. So let me use my calculator. If you have a calculator, we're going to check that as well. I'm going to do square root of, it means my science calculator, okay? That'll be 0.4 times 0.6 divided by 300. Okay, close parentheses. And I got my answer will be 0.028, right? 28 again. And then 4, if I want to do more, okay? But I can just round it up and give you as 0.28, 0.28. Okay, so let me check the answer that I had before. I can just say this is equal to 2.8% if I want to, but I don't have to put a percentage in fact. So let's check the answer that we had before. Let me just go scroll up a little bit to see what was the answer they had. So I can answer Mr. Jacob's question. Let's see carefully. What was that again? Let's look carefully. I think it's right here. See the answer? So now error is 2.8. Did I answer a question, Jacob? Okay. So this formula, you need to keep it in your notes. So you have to write it down. So you can remember this is called scenario formula. Whenever you need to find a scenario error, that's what I'm going to be using. Again, as a reminder, this letter will be changed. If it's for mean, you're going to have mu x bar and sigma x bar. Okay. So here, this is for proportion we're doing right now. right here for proportion. If you have to do the mean, this will become mu x bar, and this one be sigma x bar, okay, equal to. There's a different formula for that. We will talk about it in the future, but not now, okay? So I'll talk about it in the future. So we do not get confused. Just put that, this is different. Now we're doing for proportion. Okay, quick thing about this one. The mean of the sample distribution is equal to the population proportion. We just said that earlier. If the sample is increased by a factor, then the standard error will be decreased by the square root of the factor. Okay, so that's just definition for you to read and try to understand. Give me 1 minute, please. 1 minute. 1 second. Okay, so does anybody have any question for me? Where's my calculator? Any questions? Any questions before I continue? Okay, I don't see anybody talking, so I'm gonna be doing an example right now. I did an example. Here we have, for example, this one say 65% of insured women get annual pap tests. They say to find the mean and standard error for the sampling distribution with sample size of 500. Can you guys guess what the mean will be? Here, as I told you before, this is an average rule for mu p hat. That's mean interval for proportion. What I think the mean will be. Question is open discussion. What I think the p hat will be. Again, let me remind you what we did earlier today. We say that the mean of the sampling distribution is equal to the population proportion. We're talking about proportion here. This is equal to the population proportion, okay? So what I think this will be, if I say the mean of the population, what I think the mean will be. What do you guys think the mean will be? Okay, notice that what we think the population proportion will be. What I think the proportion is. What is P here? You see, only 65% of women get annual pap tests. What I think the proportion will be. Proportion of women will get annual pap tests. I mean the proportion, not the number of people. What I think the proportion will be. Proportion is a percentage value. A proportion is a percentage value or decimal value, not a whole number. Thank you. That proportion will be 65%. The mean will be just 65%. That's why I say it is equal to that value. Okay, that's 65%. Now, to get the standard error, we have to put it inside the formula. You got for 500 people, you're gonna say the square root of gonna be 65.65 times, now 1 minus 0.65, that's gonna give you how much? That's gonna give 0.35 divided by 500. So using my calculator, I want to say the square root of 0.65 times 0.35 divided by 500, okay? So using my calculator. So that probably will give me some values, okay? Did anybody try that to find the answer? What I think this will give you, you plug it in the calculator, do square root of 0.65 times 0.35 plus divided by 500, not plus, divided by 500. That's a division sign. So what do you guys find for that? We try to get the standard error. Thank you very much. That's going to give you, where's my cursor? 0.013, 213. Thank you very much. Okay. That's the standard error. And you can, if you want, you can express it in decimal places. You can, this is about 2.13% if you want to. Okay. So that's what I got right here. I can say this is 2.1% if you want one decimal places. Okay. Okay, so right now, what I'm gonna be doing here, we do have other software to read it. This one just read it through because I do have questions about it, but this can be just straightforward exams. So this one, if the P is unknown, it's not going to be calculated, something like that. And then notice that P is always an estimate for P. P hat is an estimate for EV. That's what we want to do. Suppose you don't have the P. If you are not given the P, but if you can find P hat, you can just put P hat in the formula as well. This is also acceptable because P hat is trying to express P. You can just substitute P hat for P. That will give you also the same concept, the same idea. Again, this is not an exact science. This is just to get an idea of what about the population. Okay. I do have a couple of stuff I'd like to teach you, but what I want to do now, let me see. I don't want to introduce the concept right now. You know what? I'm going to stop here now. We're going to continue on Thursday because I don't like to introduce two new concepts in the same classroom. But because I was expecting more questions, but you guys don't have that much questions. So I don't want to talk on the same classroom. So I'm going to stop here and Thursday I'll continue for another concept. Okay. And also do a couple exercises if needed. And also use what do you call it again? Start crunch as needed. By the way, you're allowed to use start crunch on the exam, okay? So you can use start crunch to do your test. So you have an option to use the scientific calculator that is there. And in support for if you don't have a TR-83, if you don't have a TR-83, you're allowed to use the start crunch, right? So have a good night, everyone. If you have any question, please stay with me, and I'm gonna end the session. No, I'm not gonna, and I'm gonna say if you have any questions, just a little bit more. But if nobody have any question for me,